Oh yeah, here we go into some more challenging levels of inverse trig integration. So when you get to an antiderivative and you're like, I don't know what to do, I have no process that I know, but I think it might be inverse trig, then that's like your last case scenario, right, that you try, or if it's on an inverse trig test, obviously. Again, these are not going to be on an A, B, or BC exam, but they could be on a professor's test or certainly on a teacher's test. So let's go over them. So these involve completing the square, and you might be like, what? So I do completing the square. I'm going to go over that. If you need review of that, check that out way back in Algebra 1 or Algebra 2. So I'm just going to go over how to complete the square briefly in these, and then we're going to go over one final problem in this video. It'll be sweet. So x squared minus 2x plus 4. Now, I can complete that square. I can't factor it, so I'm going to complete the square. What I do to do that is I take this middle term and I divide it by 2. So that gives me the completed square part. I put it in x minus 1 squared. Now I look at this and I know I've got a plus 4 as part of the function. But when I do this and I FOIL it out, I'll get x squared minus 2x plus 1. Now there's a plus 1 that we just magically added to the problem. So at the same time I subtract the 1 that got added in when we square this out. So that gives me x minus 1 squared plus 3. So essentially the formula is this. You divide this number by 2 and then you figure out whatever that number is squared and subtract it from the problem. All right, so we squared out the 1 and then subtracted it from the problem. So that is my new antiderivative that I'm going to be taking. So I just manipulated this, x minus 1 squared plus 4. And you might be like, well, how's that inverse trig? Here we go. Now looking at this, this is u squared and this is a squared. Right, so that's 2 squared, which is a squared, and this is u squared. So u is equal to x minus 1. A is equal to 2 in the format, right? So remember our formula, it's that it'll be 1 over a arctan, that's arctan, of u over a plus c. Well, if u is x minus 1 du, I'll put a dx here, is equal to dx. And so now I like to put that in template form, so dx is du. U is x minus 1, so we get u squared plus a squared, where a is equal to, again, 2. And now we just plug it into this formula here, which we've gone over in the previous video and why it works. 1 over a, which is 1/2, arctan of u over a. Well, u is x minus 1 all over a. And you could differentiate that till the cows come home. You'll get your original value back. So that's difficult. You've got to complete the square on that one. This one as well. I'm going to factor out the 4 because I don't like it there. Let's get rid of it. We get dx over root 8x minus x squared. Now looking at this, it's like, well, how do I complete the square on this one? Again, I'm going to do something very, very similar. So as is, I don't know what to do, but if I complete the square, maybe it's arc sine, maybe. So what I do in here is I'm going to first, I like to factor out a negative. That's just what I like to do in all of the completing of the square stuff. But you don't have to, right? So it's completely up to you. So we'll try to do it without it. You divide this by 2. You're going to get, in that completed square bubble, just this part, I'll do this work over here, you get 4 minus x, that quantity squared. And you might be like, wait, what? Where are you getting that from? Well, I divided this number by 2. And what I have here is, I've got the minus x part. When I square this out, though, I've got an issue. I'm going to end up with a positive x and a negative 8x. So I take out a negative there to make sure that when I do this out, when I square this, I'll get a positive x squared, negative x squared. Boom. I'll get a negative 8x, negative 4x and negative 4x from this, times a negative is a positive 8x. So that's the difficulty. And remember, you're squaring a 16, so we added 16 into it, minus the 16 from it, so you're going to have to add a 16. Because out of this, when you square that out, when you FOIL it, you'll get a negative 16. There's no negative 16. Plus 16 is 0, so that cancels it out. Oh, it's nasty. It's definitely tough. So we get the integral, the antiderivative of dx all over the square root of all of this mess. I'm going to write that as 16 minus 4 minus x, all of that, squared. Ugh. Okay, pretty darn gross. I know. I get it. Okay, so now from here, what do we do to simplify all of this down? Well, I'm going to let u, because we've got this as u squared, that's 4 squared, or a is 4. So I've got u is equal to 4 minus x. I've got du is therefore equal to a minus dx. And then I've got that a is equal to 4. So I plug and chug. Now remember, our formula is that we'll get arcsine of u over a as long as it is coming from the antiderivative of du over the square root of u squared minus a squared. That's what we're looking for here. Okay, let's work it out. So what I've got here is a 4. I need that negative dx, so I put in a negative, so I get negative 4. So I get negative 4 antiderivative of, there's my du, perfect, ready for us, all over the square root of, remember that's a squared minus u squared. It's set up for us. So this will be equal to negative 4 arcsine of u over a. It's set up perfectly. And now we'll plug in everything. So I've got negative 4 arcsine of u, which is 4 minus x, all over a, which is 4. Oh, dear goodness gracious, that was a difficult one. Very difficult one. All right, we got one more. One more to do. Let's do it. So here we've got the antiderivative of x minus 1 over root 36 minus x squared. Now, this problem is just gnarly. All right, if you happen to recognize it, then great. Right now, it's not quite, and we need a dx there, but it's not quite in arc-trig form. But if we split it into 2 integrands, we actually get a combination of integrals to take. So I've got minus from that minus sign, and then this will be dx, of course. Dx all over the square root of 36 minus x squared. So what this is, if you take a look at it, is it's just splitting up over the same denominator. We're allowed to do that, right? So we do that, and we're going to integrate each piece. Now, the one on the left is actually u substitution, because u equaling to this denominator is going to actually simplify nicely with that. We'll see that in a second. This one is perfect arc-trig. This quite literally is a squared. You have 6 squared minus u squared, x squared. So if we let u equal to, on this one, x, and we let a equal to 6, you're going to see that you've got the integrand of du over the integral of a squared minus u squared. Nice. And that, of course, equals to arcsine, maybe not of course, arcsine of u over a plus c. These are nasty problems, right? These are the most difficult of the arc-trig ones. You might never see these. But if you do, I got you covered. So I got arcsine of u over a plus c. So we'll do this one out. So I've got minus, and now this result right here is going to be, well, I'm going to have arcsine of u. U is x, all over a, which is 6. We got the plus c. Now, let's deal with this one on its own. So I'm going to take that one off, and I'm going to do it all over here. So we'll do the work over here. Now, this antiderivative off to the side, if I had given it to you before you learned everything about arc-trig, you'd be like, dude, it's easy. But now that you see arc-trig, you're seeing this and you're thinking, whoa, this is arcsine. That's what's involved here. Before you go to arcsine, try to figure out u sub, or something a little bit more common, right? So if I let u equal to 36 minus x squared, then du is going to be equal to negative 2x dx. We don't have a negative 2, but let's put it in there. So I've got negative 2, and that'll be a negative 1/2. Nice. So now at this point, negative 2x dx is du. See where this is going? I hope so. So I got negative 1/2. Du is up top right there. So I've got du all over. Now I've got the square root of u, right? Which is just u to the 1/2, square root of u. So that's the same as negative 1/2 times the integral of u to the negative 1/2 du. Nice. We integrate that like normal. Add 1. That's negative 1/2 u to the 1/2. And then you multiply by, well, normally I divide by 1/2, which is multiplying by 2. Normal old integration. This is going to be negative u to the 1/2 plus c. Well, what's that? Well, that's going to be the opposite of u was 36 minus x squared. To the 1/2 is square root 36 minus x squared. So I plug that in there, and we've got ourselves our antiderivative. So when you have something that can be split into 2 different fractions, that might lead you to the promised land, but not always. That is very, very difficult. The previous problems with completing the square, also not easy. These are of the most challenging variety. Some professors might ask you to do that. Most teachers in high school won't. A, B, and BC Calc, none of this is going to be on there. But I wanted to go over it to cover you because it's still in the calc, and that's what we're into. Peace.